So for this video, we'll be looking at using matrices to solve simultaneous equations. So you're given a simultaneous equation such as what's written here: 2x plus y equal 5, x plus 2y equal 4. So to solve it using the matrix method, there are a few steps. Step 1 will be to write the simultaneous equation in the matrix form. So the matrix form of a simultaneous equation requires you to make it into 3 separate brackets. Alright, so 3 brackets. Bracket 1 here requires you to put the coefficients of the variables in it. So whatever number comes before each variable or is attached to each variable, you'll write it in. If there's a negative sign before any of the numbers, you must take it into account. So step 1, look at this variable here, the number before, 2. So you write 2 at the top. Come across, this is just a y. So once you see a variable by itself, the coefficient is 1. So you'll put a 1. Same thing here, 1. Here is 2y. Second, you will write the variables that you have, x and y. Those are the only 2 variables that you have present. The variable that comes first, put it at the top. The one that comes second, put it beneath. Equal, whatever numbers are written there for your answers for each simultaneous equation, you'll put them in the final bracket, 5 and 4. Now that's step 1, filling in the numbers or the terms in the matrix form. The second step rather, is now to put or find the inverse of this matrix. Whatever matrix is on the same side of the equal sign with the variables, you'll have to find the inverse of that. So this is the matrix that you'll have to find the inverse of. So the inverse of a matrix, that requires you to multiply the leading diagonal. So that would be 2 times 2 minus the other diagonal. So that's minus 1 times 1. So that's 2 times 2 is 4. Minus 1 times 1 is 1. So that gives you 3. So that gives you the determinant. Then you would, after you find your determinant, you find your adjoint. The adjoint is to switch the leading diagonal around. So that would be switching 2 and 2 switched, you will still get them back in the same position. And then for the other diagonal, you will change their sign. So since it's positive 1, you make it become negative 1. So that's the adjoint. And then the inverse is to multiply 1 over your determinant by whatever your adjoint is. So that's 1 over your determinant, which is 3, multiplied by your adjoint. So that's 2, negative 1, 2. When you multiply, because 1 is the numerator, you can just basically multiply each number in the bracket by the 1, or you can just write it above, because 1 times anything will always give you the same number. So that's 2 over 3 first, then negative 1 times that gives you negative 1 over 3, negative 1 times that, negative 1 over 3, and 2 times that would be 2 over 3. So that would be the inverse of this matrix. Now when you find the inverse answer, you will now go and multiply whatever your inverse was. So you're writing back the inverse. And then you multiply it by whatever the answer was for your original simultaneous equation. So in this case, it was 5 and 4. So you'll write back 5 and 4 beside of it. Now, you'll do multiplication of matrices. Now it's the first by the first, second by second. So if you will do row by column, the first in the row by the first in the column, the second in the row by the second in the column. So this will be 2/3 times 5. Plus the second, which is negative 1 over 3 times 4. And then because that row is finished with that column, you will now go to the next row and the column. So it's negative 1 over 3 times the first, which is 5, plus the second, which is 2/3, times the second, which is 4. From that, you will simplify. So writing the simplified here, 2 over 3 times, or 2/3 times 5, that would be 10 over 3, plus negative 1 over 3 times 4 would be negative 4 over 3. Now, 5 times negative 1, that would be negative 5 over 3, plus 4 times 2 here is 8 over 3. And then you simplify further. So this is saying 10 over 3 plus negative 4 over 3. So 10 plus negative 4, that is basically saying 10 minus 4, that would give you 6. So that would give you 6 over 3. And here now, negative 5 plus 8. So that's saying 8 minus 5. Basically, that would be 3. And that's 3 over 3, because you must keep your denominators. Now, when you get here, you just simply simplify as best as possible, meaning you divide your numerator by your denominator. So 6 over 3, that's saying 6 divided by 3, which would be 2. And 3 divided by 3, that's 1. So since you get these, all you need to now do is write it back to say which variable is equal to each. Now, remember here, x was at the top, so it means that the number at the top is your x. So you can say, therefore put the 3 little dots, x is equal to 2. And if x is equal to 2, y is at the bottom, so y would be equal to 1. And if you get their answers and you're not 100% sure, you can always just simply substitute them back in the original and see if you'll get the same answer. So it would be 2 and 1. So x is 2, y is 1. So 2, and put your little 2 here, 1. So 2 times 2, that's 4, plus 1, that's 5. So that would be correct there. And if x is 2, so 2 plus 2 times 1 is 2. So 2 plus 2 is 4. So that would be correct. So that's how you solve simultaneous equations using matrices. First, put the simultaneous equation in a matrix form. Second, find the inverse of the matrix on the same side with the variable. And third, you will multiply the inverse by the original answer for the simultaneous equation. So I hope this video will have helped you understand how to solve simultaneous equation using the matrix form. And tune in again with Mr. Brown while I explain other mathematical concepts.